Similar to the arrival, we also expect some anomaly or some extraordinary behavior in terms of the service time. That is, the packets which are in queued would be serviced, but their service rates could vary. If that is going to be the situation, how would an incoming packet that is about to be served into the system would look at the system? Is it going to look at the system as a non-exponentially distributed service time system or otherwise? That is what we are going to explore in the departure occupancy distribution. We shall understand what do we mean by non-typical departure, and again compare it with the typical departure, and then we'll draw meaningful conclusions from the occupancy distribution. The reference is Bertzicus and Gallagher. The system, as we earlier commented, is continuously under change. Previously, we looked at the change in the system as the arrival process. Now, we are going to look at change in the system as a departure process or as a service process. So all the packets which get served eventually have to depart. There may be a possibility that the departure of some of the packets is non-typical. The non-typical departure could be represented as a departure that occurs just before time interval time t. It means that this departure is extraordinary departure. It is happening unusual way. If we compare it to the exponentially distributed service times, the departures are also going to be exponentially distributed. But if we look at our system as a whole, we'll understand that the basic definition of a system being exponentially distributed does not have a relationship of the packets which are still occupying the system and the packets which are getting departed. Instead, it depends upon the mutual independence of the departing packets because they are getting serviced independent of each other. That is why we say that no matter how atypical the departure may be, it still is going to be the departure based on exponential service time. For each time, the number of packets in the system are going to increase, say from n to n plus 1 due to an arrival. But at the same time, since our distribution of service time is also exponential, the system is going to have a decrease in the number of customers from n plus 1 to n because the users are eventually going to find their packets leaving the system also. So the system remains in this steady state where the packets, which when they come, they get serviced and they leave. There is a temporary increase in the number of packets in the system and a consequent decrease with the departure.